Okay, so in this lecture or this lesson, we are going to talk about matter and the kinetic theory of matter. Matter is anything that occupies space and has mass. Okay, so just anything that occupies a space and has mass, okay, something that can be weighed, all right, and it occupies a space, anything, then it's matter. So it can be solid, liquid, or gas. All right, okay. So let's look at the next one is we need to clarify the basic units of matter. So we have what we call atoms. We have what we call molecules. And we also have what we call ions. Okay, so the particles found in matter are atoms, molecules, and ions. Okay, now let's try to clarify the state of matter. Let's look at the kinetic theory in terms of how the particles are arranged and how they move. So we are going to start with solids. Okay, so with the solid, we are saying particles in a solid are closely packed and in constant vibration in their fixed position. What does that mean? The particles that are found in solid, they are packed closely together. Okay, they are close to each other. And when it comes to movement, they only vibrate. Okay, they vibrate. Okay, within their fixed position. Okay, remember we are talking about the particle arrangement in solids and also the particle movement. So what is the particle arrangement in solids? The particle arrangement in solid is they are closely packed together. What is the particle movement? Constant vibration. That's the particle movement within their fixed what position. Let's go to liquids. So with liquids, particles are not packed like they are packed in solids. Okay, in this one, distance between particles of a liquid are far apart from each other. And other one as compared to the distance between solid particles, and they move about randomly. Let's check on gases. So the particles that make up a gas are very far from each other, very far from each other. Okay, and this is why gas easily compressed. Okay, you can put, some gas in a balloon and compress the balloon. But when you try to, the particles here, in a solid, they are closely packed together. In liquids, you can see some spaces, all right, meaning that there's a difference between the liquids and gases when it comes to the arrangement of particles, all right. In a liquid, they are spread, all right, at least far away from each other. But when you look at gases, it's very far away from each other, from here to here. So the gaps, all the spaces that are being left out are big. And that gives what the opportunity, for the compressing of the gas in whatever container they are put. We're going to look at the characteristics. Okay, then the state, we only have the three states that we're going to talk about: the solid, liquid, and gas. Then we are going to talk about the characteristic of each. Then we also need to look at how the particles are arranged. Then we're going to have an example of, what those states of matters are. So let's start with solid, liquid, solid have fixed volume. They are fixed volume. Apart from having fixed volume, they also have a fixed shape. Okay, so you always find that solids have fixed volumes and fixed shapes, right? Because of how the particles are packed within a solid. Okay, so to change the shape of a solid, it requires force. There must be some force that needs to be applied for the shape of that particular solid to change. There must be force applied, such as when it is broken or when it is cut. Okay, when it is broken or when it is cut. All right, that means you are going to see, you know, some force, or you're going to apply some force on it for the shape to change. Okay, now what are some of the examples of solid? We have a lot of examples of solids. Anything that has volume, a fixed volume and a fixed shape, with particles packed closely to each other, and the particles only vibrate, okay, then those are solid. So we have stones. A stone is an example of a solid. Ice block is an example. A table is an example. All right, salt is an example. Wood is an example. Okay, those are just some of the examples of solid. Let's check on liquids. Liquids have fixed volumes, yes. This is one of the similarities. They have a fixed volume, but the difference is that they do not have a fixed shape. Liquids do not have a fixed shape, meaning for it to have a shape, it has to be put in a container. All right, it has to be put in a container. A liquid can change shape, its shape, and take on the shape of the container where the liquid has been put. For example, you can put water in a jar, you can put paraffin, you can put cooking oil in a bottle, and it will get the shape of the bottle. So it doesn't have its own shape. Okay, why? Because when you pour it where there's no container or anything like that, then it will start flowing. All right, it will start moving, okay, going to where there's a lower slope like that. It doesn't have a shape. So if you only want to see its shape, you are going to need you need to put the liquid into a container or a bottle, or, you know, a plate or a pot or anything like that, and it will take, the liquid will take the shape of that particular container that you're using. So this is exactly the characteristic, okay, of liquid. Then how the liquid particles are packed. All right, you can see that there are some spaces, but not as in gas, right? Then these are just some of the examples of liquids. Let's look at gas. Gas, the features of, I mean, the characteristics of a gas is, this one is totally different from the other two. No fixed shape, no fixed volume. Okay, it doesn't have a shape, it doesn't have a volume. A gas will expand to take the full volume of the container it is in. So this is how gas is packed. All right, like, I mean, they are far away from each other. You can see the particles are far away from each other. Okay, examples of gases, we have oxygen, you know, carbon dioxide, we have chlorine, the chlorine gas. There's chlorine liquid and chlorine gas, right? Chlorine gas, we have hydrogen, we have, you know, there are a lot of gases that we can talk about. Carbon monoxide, all those are gases, right? Now, let's now look at the change of state of matter. Changes of state of matter. Let's start with melting. Melting, kusungunuka, melting. All right, melting. If something is melting, it means it was a solid. Okay, it was a solid. It was something hard. It's easy melting into liquid. Chisungunuka into water. Okay. What causes the change of solid to liquid is the increase in temperature. How the particles are packed within that solid will be different from how they are going to be packed in a liquid. So there'll be a change of the distance between the particles within that particular change that has done. So that is melting. Then we have freezing. Freezing is the opposite of melting. Freezing, you're getting either a gas or you're getting liquid and changing it into solid. You're making water into an ice block, right? So liquid is now changing to solid. So that change is called the freezing point. Okay, the freezing point. And also temperature temperature affects that, right? This time we said increases. When temperature increases, then that would be melting. When temperature decreases, then that would be freezing. So the freezing point is the change of state from liquid to solid. Then the distance between particles of liquid reduces until solid state is achieved. What of the boiling? Boiling, you are boiling a liquid into a gas. So boiling point, boiling, when you're boiling water, water is what? Liquid. Then steam, choose, steam is gas. Condensation is the opposite of boiling point. All right, it's going to turn into liquid. Okay, okay. But when the gas, that gas hits a cold area, then it begins to do what? To condense. We have sublimation. Now, with the sublimation, this deals with the solid and gas. It's either you are changing solid to gas or the vice versa, gas to solid. So this has the same name. Okay, you are changing a gas directly to a solid, or from a solid directly to a gas without passing through the liquid state. It's just changing direct from solid to gas without passing the liquid state, or changing from gas to solid without passing through the liquid state. We have evaporation, or what we call vaporization. Evaporation. From solid to liquid and from liquid to gas, from solid to liquid and from liquid to solid. These are two opposites. So melting and freezing, they are opposite. When you are freezing, you are changing an ice block into water, that is melting. When you're changing water into an ice block, that is freezing. Okay. Then the other opposite is boiling and condensation. Boiling is from water to a gas, which is steam, and from steam back to water, it is condensation, right? Now, when the solid changes directly into a gas, or the gas changes directly into a solid without passing through the liquid state, then that is what is called sublimations. Okay, so there are even some examples of states of matters that sublimes, right? Now let's go to describing the absorption of heat. Remember, the change of temperature causes some states of matter to change to the next state of matter or to the other state of matter. It is because of the temperatures that is changing. Either the heat is increasing or the temperature is decreasing. So now let's look at the absorption of heat. Number one. Number two, we look at the release. Absorption, the taking in. Absorption means the taking in or the receiving of it. The release meaning the giving out of it during the changes of state of matter. So we have to understand that the change of states of matter occurs by what we call the exothermic exothermic, exothermic, exo, right? Exo and endo, these two, right? So we have the exothermic reaction, and we also have the endothermic reaction. Okay, so absorption of heat during a reaction. What is that? Look at that. Exothermic reaction, this is the release of heat. Okay, when the state of matter is changing from one state to another, and it's giving out heat, that is exothermic. It's the releasing of it during the reaction. And an endothermic, meaning absorbing or bringing in the heat, okay, or where the heat is needed. All right, for example, when you are boiling something, right, you're boiling something, meaning you need heat to come in. All right, when you're cooling something, it means you are giving out what? Heat. So this is what you need to understand, and that is about the exothermic and the endothermic reactions. Okay, so these two reactions helps very much into this change of state. Remember, this is about the change of temperature, either the increasing of temperature or the decreasing of temperature. Then the other thing we need to understand here is diffusion. What is diffusion? This is the movement of particles from a region of higher concentration to a region of lower concentration. From higher concentration to a region of lower concentration. Particles, the movement of particles from where there are a lot to where there are few. Okay, so what are the factors that affects the rate of diffusion? We have the size of the molecular mass, we have the temperature, and also the concentration. Okay, these three affects the rate of diffusion. Okay, when let's start with the molecular mass. When there are bigger molecules, okay, the bigger the molecular mass, the slower the rate of diffusion. Okay, is temperature. When there is high temperature, let's say you've put sugar in water, in cold water or warm water, it will take time for diffusion to take place because the temperature is low. But when you boil water, you put sugar in hot water, okay, diffusion will take place faster because that water has a higher temperature. Okay, so higher temperature particles move faster. Hence, that makes the rate of diffusion to be faster. So when you want the sugar particles to dissolve faster, boil the water, right? When you boil the water, you put sugar there. The particles the sugar particles will dissolve faster than when you put in cold water. Why? Because of the temperature. So we need to understand, say, the other temperature of the particles, then the faster the rate of diffusion. Okay. The other factor is the concentration. The concentration. The higher the difference in concentration, the faster the rate of diffusion. The lower the difference in concentration of the two substances, the lower the rate of diffusion.